Derivations you may need presence. Electric field intensity at the center of a charged arc. Suppose we are said to find out the electric field intensity due to an arc, which is part of a circle of radius r. At the center, let's say this point P. The arc is symmetrical in nature. We draw coordinate axes and place the arc symmetrically across the axes. Let the arc subtend theta angle at the center. On one half, let us assume a very small part of the ring dx. Let this small arc subtend d theta angle at the center. Let vector of electric field intensity due to this dx part be dE vector. Let this vector make phi angle with horizontal. This angle will also be phi. Breaking the vector into its components. Since the arc is symmetrical, we also assume another dx part at the same distance from the axis. For two symmetrical parts, the dE sin phi component gets cancelled as they are opposite in direction, while the dE cos phi part coincides. Thus, only dE cos phi remains. Electric field intensity due to dx at point P will be 1 by 4 pi epsilon 0 dq by r square. dq is the charge possessed by the dx part. For unit length the charge is lambda. So for dx length charge is lambda dx. Thus dq is equal to lambda dx. We already saw this earlier. dE sin phi were in opposite directions and thus cancelled each other. So integration dE sin phi is 0 as for every dx part there is another dx part that cancels out the sine component. E is equal to integration of both the sine and cosine components of the dE vector. Since the sine part is 0, only the cos part remains. Putting the value of dE. Taking out the constant parts. We know arc equals radius into angle. So dx is equal to or d phi as the dx part subtended d phi angle at center. R is constant and we take it out. Cancelled one r and now we have to integrate cos phi d phi. Putting the limits from minus theta by 2 to theta by 2. Integration of cosine phi is sine phi. Evaluating the limits. We get 2 sine theta by 2 after integrating the cosine phi d phi. This is our final result that we should remember while doing problems. Using this formula, we can find out the electric field intensity for a semicircular arc. We just put the value of theta as pi and we get the result as 1 by 4 pi epsilon 0 2 lambda by r. Similarly for quarter arc, we place theta as pi by 2 and get the result as 1 by 4 pi epsilon 0 root over 2 into lambda by r. Check out the video on my channel where I have shown these results using integration method. Link is in description and on end screen of this video.